Welcome back. In this video series, we'll take a look at methods of proof, direct proof, as well as indirect proof, proof by contrapositive and by contradiction. We'll start off with a recap of the rules of inference and where that has taken us. So first we talked about what it means to be a valid argument, and we learned some rules to play by. So we learned about the rules of inference and how they apply to propositional logic. Then we looked at how we could use those rules of inference to build valid arguments. We then took the rules of inference and we applied them to quantified statements, so those that use the universal and existential quantifiers for all and there exists. And then we took that and used that knowledge to build arguments for those quantified statements so that we could draw some conclusions. As a first example, we'll use the rules of inference to construct a valid argument to show that Angela is mortal is a consequence of the two premises, every human is mortal and Angela is human. So we need two predicate statements to start this off, and we'll let the first be h of x, where h of x denotes x is human, and m of x will denote x is mortal. And we'll let A represent Angela, a member of the domain of interest. And so what we want to do is find that we can move from one step to the next. So first we have to figure out, what do our premises say? Well, the first premise, every human is mortal, because we now have this notation, what this means is we can write this out. And this says for all x, if x is human, then x is mortal. And that's a quantified predicate statement that we can create. The second premise gives us that Angela is human, and we're letting a, lowercase a, represent Angela. And so that gives us h of little a. And what we want to show is Angela is mortal. And so we want to show m of a based on these predicates that we've created. Okay, so we have two premises, and let's make use of them. We'll start off with the first premise. For all x, h of x implies m of x. If x is human, then x is mortal. And then we can layer on universal instantiation. And so universal instantiation from that tells us that if this is true for all members of the domain, then if I pick a member of the domain, Angela, it must also be true for her as well. So if it's true for everybody, it's true for Angela. And so if Angela is human, she's also mortal. But we have one more premise that we can make use of, and that is that Angela is human. And so with that premise, these two combined give us something really important. We now can make use of modus ponens, and modus ponens, when we combine 2 and 3, gives us that Angela is mortal. And you'll recall that modus ponens, in another video, if we have P implies Q, and we know this is called the mode that affirms, we see that the antecedent is also true, then from modus ponens, we can say Q must be true. Let's look at another example. If we use the rules of inference, can we construct a valid argument to show that someone who passed the test didn't study? If we know that the following premises hold: a student in the class did not study, and everyone in this class passed the test. So to start us off on a solution, let's first define some predicate statements. We'll let C of x denote that x is in the class. S of x denote that x studied, and P of X will denote that X passed the test. So the first thing we want to do is translate the premises and the conclusion into a predicate statement. And they'll be quantified predicate statements in some situations. So let's look at predicate 1. So the first predicate says, a student in the class did not study. And that A is a giveaway for existence and the use of that existential quantifier. So what this tells me is that this is going to look like there is someone who is in the class, the student is in the class, and they didn't study, not S of X. The second premise is everyone in this class passed the test. And so anytime you see everyone or all, that's a clue that we're going to use the for all. Okay, so for all X, X is if they're in the class, they pass the test. So everybody in the class passed the test. It might be tempting to assume that we would just go straight to for all X, they pass the test, but they must be in the class to have passed this test. And so in fact, this is an implication scenario. If they're in the class, then they pass the test. It would be hard to pass the test if they weren't in the class to take it in the first place. Okay, and then our final piece is to figure out how do we represent that conclusion. So again, we've got a keyword that we can latch on to give us a hint, and that's someone. Someone who passed the test didn't study. We don't know who, but it doesn't say everyone, it says someone. And so in that scenario, we're definitely looking at there exists. So there exists a person who passed the test and didn't study. We can write that out. And what we see is what we want to show is that we've got the two premises at the top, and you'll see they're color coded. Those premises hold, and we want to show that putting those two premises together and making use of the rules of inference, that we can conclude that there exists a person who passed the test and didn't study. And from looking at these sentences, you want to believe it. You know it's true. But we still have to go through those mechanisms to make sure that that's in place. And that leads us to proof.